All right. So as the slides show here, Derek and I are here from the Great Plains Network, which you just heard about from Mickey. We're here to talk a little bit about building user bases with some examples of what we've done and how we've overcome a lot of the challenges towards NRP adoption in the Great Plains Network. So as I think everyone here is aware, the NRP offers a wealth of resources and expertise to both researchers and educators, but expanding NRP adoption within academic institutions still remains a significant challenge. We've identified 3 different types of challenges that we're going to talk about here in this talk. The first is a technical type of challenge. The next is logistical, and then the third is a policy. In general, MU, UNL, and the GPN community in general have been able to overcome most of these obstacles to foster a growing NRP community. And here for the next 20, 25 minutes or so, we're going to highlight some of the key challenges we faced and how we mitigated those challenges to overcome them to the best of our abilities. So first, what are the challenges that we've kind of identified that were key to the growth of GPN adoption to NRP? The first and most relevant from a research perspective is the technical challenge of understanding containerization, distributed computing, all of those kinds of concepts. A big part of this, at least for MU, was that there really isn't any point in the undergraduate or graduate career for computer scientists where they learn these concepts, right? They've likely heard of a VM, but there's not really any core competency of students to know what Docker is or what containerization is or Kubernetes or distributed computing. And so that brings us to a problem where for most of the funded efforts, those things are being done by graduate students, right? But those students have never heard of these concepts. And so that technical barrier is probably the biggest hurdle to overcome NRP adoption from a research perspective. From a teaching perspective, the technical challenges include things like setting up Jupyter hubs, right? And even if you can take care of things like that, you have to integrate them oftentimes with LMS systems, right? And then also you have to help instructors kind of buy in to help build their own containers and then transition the material from the old to the new. And so those are some of the most consequential technical challenges we've seen. From a logistical perspective, the 2 that we've identified for research would be, first of all, how to transition kind of that experimental workflow into the NRP. Right, so beyond that technical aspect of actually building containers and starting the jobs, how do I do reproducible research that I can use to publish or for whatever thing I'm trying to do on a distributed cluster? And then sometimes even harder than that is the data side. Once I figured out how to start a job, how do I get all the data I need to use onto the NRP? And we've heard about that a lot today already, about all the different ways and different kind of mitigation strategies, but we'll touch on that a little bit here as well. And from a teaching perspective, like I said, how do I transition what I'm used to teaching, maybe a textbook-driven course, chalkboard-driven course, and take that kind of concept and bring it into the NRP? How do I move from PowerPoint to Jupyter? How do I build assignments? How do I assess student learning? And how do I build lessons inside of Jupyter? And then the last family, policy challenges. Every university has kind of a diverse implementation and interpretation of the security policies needed for NRP. Some universities do not know about or do not allow science DMZs or may not allow any incoming connections at all. Additionally, the public data requirement, while generally not too hard to work with, can stand in the way for some researchers. So a lot of funded projects oftentimes will use things like government data or PII data, and so that public data requirement will mean that they can't directly use NRP for their research goals. And then from the education perspective, the public requirement of data means that grading can't necessarily happen directly in NRP, right, because of FERPA compliance issues. And so a lot of times you have to move the work out of NRP into some kind of FERPA compliance system to actually do the grading and feedback. Then the last one that doesn't really fit in any of them, but I think everyone knows about, is the awareness problem of how do I make sure researchers and educators at my institution even know that this thing exists. Especially when a lot of universities might have some small on-prem resource, but oftentimes that's not going to be the best fit for every educator or every researcher, and NRP would be a much better fit for what they're trying to do. So now that we've identified these challenges, we're going to go through each of these key ones we've identified and talk about how we in the GPN were able to mitigate these and kind of some of the solutions we took to try and build in NRP adoption despite these challenges. The first, right, the one I said was most likely the number one reason that NRP adoption is hard from a research perspective, is that familiarity of Docker and Kubernetes to both PIs and graduate students. And so how did we mitigate this? One of the primary ways was hands-on trainings. And so we would actually have lecture and Jupyter components that introduce these concepts to researchers, grad students, PIs, and anyone else interested at given GP member institutions. This is a big part of the mission of the GP Engine project that Mickey was just talking about in the last section. Another key thing we found was making sure everything we were building was open source. I think everyone in this room probably is very pro open source software, right? But we found that, if one student or one PI came to our trainings and learned a lot and everything was open source, they could send that link around to everybody. And so we'd see a many-fold multiplier, right? By getting one person up to speed, they can teach other people at their own institutions. Another big thing that we found worked was sharing success stories. So there's quite a big technical gap at times, right? And so, PIs, if they have, deadlines or timelines for their projects, trying to convince them to set some time aside to learn all of this, to get up and running, can be difficult. And so sharing with them what others at their own institutions or in their own regions have been able to do with that buy-in of time has also helped get more people to be willing to take that jump. Next is more locally sourced forums or online chats. Obviously, the matrix for NRP is outstanding, but some of the problem is that you don't know anybody there, right? You go and you post a question, you might not know the person who responds. And so we found that creating one specific for, we had an MU one when we were building up our user base at MU, and we still have it today. And so that can be very helpful, because that way with the people who are responding to you or people you maybe have met, people from your own department or your own college. Then the last one that you've already heard about plenty throughout, this NRP is the software carpentries course. This is going to be another great starting point for people who are trying to get into the technical aspects of Docker and Kubernetes. The other major technical challenge from a teaching perspective is the idea of building course-specific containers, right? Even if we take out the Jupyter Hub creation portion, there's still the issue of, if you're teaching a course that has specialized software, then that instructor or someone near to that instructor is going to have to build a container that can actually be deployed inside of that Jupyter Hub. And so one of the ways we mitigated this challenge was by utilizing that inheritance capability of Docker, right? If you have a great base container, then it's very possible you only need to add 1 or 2 lines to a Docker file in order to get it from where the base container is to where it needs to be. Another great way we helped mitigate this challenge was to build common ones. So having one for AI ML, having one for certain types of data science, certain ones for geospatial science, and things like that will make it so that instructors in those departments don't have as much of a technical gap to go from what's already created to what they need. And like I said, the Jupyter Hub can be mitigated a little bit easier by centralizing that to technical experts, right? So rather than having every instructor have to manage their own Jupyter Hub, you can instead centralize it to either the department or the college level, so that there's maybe one for an entire computer science department or one for an entire college of journalism or something like that. And then one technical expert can make sure things are deployed and running and not put that on the instructors. And then again, success stories. I said that for research, it holds here. Sharing, what kind of assignments you're able to create, sharing what kind of hands-on material you're able to do within a given field can help inspire other educators to take that same jump. And so that was our solutions for looking at the technical challenges. For logistical challenges, our first one that we identified was how to transition those experimental and scientific workflows from a single workstation to the NRP. A lot of the people that I've talked to are used to working on a single workstation sitting in their lab, right? Their data's just on their Windows hard drive. They're running VS Code or something on their local computer. How do I transition that into a distributed cluster? And so a big part of that helped within GPN were things like community-driven discussions, because generally scientists within the same field have very similar goals, right? They're trying to create reproducible and scalable compute, and so their workflows likely won't differ too much. Certainly there will be standouts that are very different from their colleagues, but oftentimes if one researcher or one educator has figured out how to do this workflow, they can share it with others in the same department. Another key thing is leaning on those technical experts. So whether that's the people who came to your trainings, right? We talked about the trainings we did, having those people and leaning on them, and or the people that come out of things like your office hours, if you do those for NRP adoption, can be very helpful, because every lab that gets going on NRP and really succeeds has at least one, if not more than one person who is comfortable with the jobs and the pods and the whole process. And so encouraging that networking between those technical experts and connecting those labs or researching groups can also help ease the logistical challenges. And then another thing that really helped, at least early on, especially when we were going from that very small number to the moderate number, was the one-on-one office hours. We talked about this a little bit earlier today, right? There's already been some discussion, but this was helpful because I would make sure my contact information was with any and all material, so they could schedule a time to jump on Zoom or something like that, and I could hear their exact workflow they were going through and help see where's the missing link, where's the piece that they aren't quite able to get. The benefit of this is that generally by the time those meetings ended, there was someone running something on NRP, but the downside is scalability, right? Because it requires time from your technical experts to actually do that. Another logistical challenge was the moving of data. I'm not going to spend long on this slide, right? I didn't know how much of today was going to already handle this kind of idea, right? How do we move data in NRP? There's been a ton of discussions about things like OSTF and NDP and S3 and things like that. But the biggest way we mitigated this that really has been mentioned was by sharing templatized YAML files that would kind of automate the process of copying things from the NRP S3 into PVCs and back. We found that helped because even if you could create a basic job with Ubuntu or whatever container, building a job that could automatically mirror between an S3 bucket and a PVC wasn't straightforward for a lot of researchers. And so sharing those templatized YAML files where they just kind of plug in their username or their namespace and gives them a ready-to-go YAML, that also helped quite a bit. And then lastly, for those that are going from like an on-prem resource to a cloud resource or to the NRP, we found that talking to those research IT teams at the universities can be helpful because oftentimes, their goal is the success of their researchers, right? So they're willing to work with researchers to get data from, whatever networking or location they have their data into the NRP. And then lastly, the last logistical challenge here is from a teaching perspective, how to transition from the traditional lecture into textbook-driven courses. We covered this in a lot more detail at one of the tutorials yesterday, so I won't spend long on this slide. Everything we talked about yesterday is kind of included on GitHub if anyone has particular interest and weren't able to make it yesterday. But the basic idea was to help instructors learn how to split a course into modules, outline the modules, build the modules, where every notebook in a given module either introduces, reinforces, or assesses a concept. And then in terms of integration back to LMS systems, we utilize the export capabilities, right? Whether that's HTML or PDF or something like that. That can really help that transition. And so then finally, the last family of challenges that we want to talk about were policy challenges. The first policy challenge we identified was that each university has this diverse interpretation of security policies. The way we mitigated this was by educating institutions about what it is if they haven't heard about it, and if they have, then kind of educating them more about the benefits. This can include the standard research IT professionals or the security IT professionals about how NRP adoption can enable more things on their campuses. Additionally, sharing contact information for security IT professionals at nearby institutions for a point of contact that have used it, right? So you can say, you haven't allowed this or you aren't too comfortable with this. Why don't we share you a point of contact from a nearby institution where maybe you've worked with them before? So there can be, more of a technical dialogue beyond what we can provide. And then lastly, meeting with teams like IT leadership to discuss updating those policies to allow for science DMZs and or NRP adoption on those institutional networks. The next policy challenge that we identified was looking at public data requirements and things like FERPA. The way we mitigated this was for projects where someone would say, hey, this looks great, you have all these resources, but my data can't comply with the public data requirement. A lot of times what they found worked for them were things like prototyping. Oftentimes it's the data that can't go on there, but not the methods. So they can still use the NRP's Jupyter or the NRP's resources to do their prototyping. Additionally, a lot of times methods that eventually need to run on non-public data can be tested or validated on public data, and that can be done on NRP. And then for things more specific, like in the neural network space, we've seen several researchers build pre-trained weights on NRP and then transition those over onto the non-public data with some great success. And then, like I mentioned, for the FERPA compliance, the exportability of Jupyter Notebooks means really you can export it however you want it to look and put it wherever you need it in order to comply with whatever FERPA regulations you need to. And so then finally, the final challenge I'll discuss here is awareness, right? This is by no means a one-size-fits-all. I think everyone has their own approach to this. But some of the things that we saw worked for awareness was trying to get lists together of people that we already know are looking into research IT, into research computing systems. This can either be gotten by word of mouth based upon who you already know in your departments, or at some institutions, the research IT team might have a list of all their users of whatever on-prem resource. getting that list and kind of, hitting them as like a mailing list of here's what can offer, here's the resources, here's my contact information. That can help address that. Another thing that can help that we did at MU at least was we were able to get a page added to like the official documentation for like research IT at Mizzou to include something about NRP to say, hey, if you're looking for more distributed or you're looking for more GPUs than we can offer or something, see the, docs.nationalresourceplatform.com, right? Something like that. And so that way there's a direct link from where professors and faculty are already looking to where they can learn more about NRP. And of course, I've already said the last one several times, right? Sharing those research accomplishments within your own institutions, within your own departments, making sure that those around you are aware of what's worked and what you've been able to do can help them feel a little bit less nervous about trying to go on this technical, logistical, and policy hurdles. So kind of a conclusion or wrap up, there are ongoing technical, logistical, and policy challenges that can hinder the growth of NRP adoption, but mitigation is doable. And we've seen that at MU, at UNL, and in GPN in general. Relying on 2 key points of success stories and NRP experts, and again, the thermal would be open source resources on a given campus or in a region are key for helping to overcome many or most of these challenges and grow user bases on the NRP. And the other major thing that I think we've learned is that making researchers and instructors aware is kind of only the first step. And so if they become aware of it, then they try and onboard or get started and they run into major challenges, a lot of times they aren't going to go back and try again. So making sure that the onboarding process is as clean as possible and that they have the people to talk to around them will make sure that NRP adoption is not only oh, let me try that, ooh, that looks too hard, to let me try that, oh, wow, this is powerful, right? And that's kind of a really big hurdle we had to overcome as well. So in terms of GPN, where are we going from here? GP Engine is continually running tutorials within the Great Plains region to bring awareness and ease this onboarding process. We did quite a few of them in 2024. We're scheduling even more for 2025 now. Next steps will be continually improving and updating the open source resources, right? I think NRP at large is doing that. We're doing that as well in GPN, where every time we run one of these tutorials, we go back and say, okay, what did we learn? Where is our documentation lacking? Where is our tutorial material lacking? What are the questions we keep getting again and again, and how can we improve it so that we get this kind of feedback loop? And lastly, increasing networking between different institutions, different colleges, different departments, within institutions and then within the region can help newer NRP users connect with experienced users and technical experts to get started. And it looks like I ran a little ahead of time, but that's all I have. Thank you.
Any questions?
I'm gonna take this down if that's okay. First of all, I want to say thank you. I absolutely loved the workshop that you did yesterday. I found that particularly informative. And for anybody that hasn't been able to attend the workshop yesterday, I highly recommend taking that link and spending an hour or two on it. The second, I would like to clone both of you and take you back with me so you can talk to my faculty and get them all so excited about what's to come. Third, in terms of the tutorials and work that you've already done for the Great Plains, I'm assuming that all of those are open to outside of the Great Plains institutions. Absolutely. For yes. Others to look at. And one thing that I found with our faculty, I have over 7,000 faculty, is that a lot of them don't have tons of time to have to dig through materials, and if they have to search for too long, unless they're really determined, they are likely to just say, this is not worth my time, I'm not going to look for it. So what I've done, not in this field, but in general, is try to provide them bite-sized video or bite-sized information that is very specific to what they need to do. So in this case, for example, how to add an OER to their container, a zero-cost textbook, to open source textbook to their container for a lecture, or how to add a link to their material or whatnot. So it's like a 2-minute thing, and that's all they need to know, and that's all they care to find. So adding something like that in the tutorials would be immensely helpful, in addition to the initial setup and whatnot, just like a quick video FAQ for certain things. And a lot of people are very visual. So anyway, I just I don't want to take more time, but I wanted to say thank you. The workshop and the presentation today immensely helpful.
Thank you.
Oh,
Yeah.
and I'm sorry I didn't introduce myself. I'm Carmen with the Los Angeles Community College District.
Yeah, I appreciate the comments. So yeah, in that same organization, right, it says course tutorial. In that same organization is where all of our normal tutorial slides are. So if anyone's looking for what we use when we run our GP Engine tutorials, that is in that same group. So that'd be available. And yeah, the video, I've heard the video idea before, but you're kind of giving me even more ammunition. So that's definitely a thing we need to look into in the future. So I appreciate that as well.
Jerry Shin with the Salk Institute. You both have had a breadth of experience working with researchers and working with classroom usage. Could you sort of crystallize for our community the similarities and the differences between research user support and classroom user support?
Yeah, I find that oftentimes, at least at MU, they kind of go hand in hand, where a lot of times what will happen is PIs will find NRP for their research capabilities because they need to run faster. They have more HPC needs than maybe the on-prem resources can meet. And then when I turn around and say, hey, everything you've already learned, you can leverage that to teach your classes better, it's a very natural transition. For those that have come in where they are one or the other, I found that generally people have trepidation about the technical leap on both sides, but that technical leap for the teaching side is more, how do I make sure that this works for my students? Whereas for the researchers, they're a little more willing to trial and error, at least that I've found, where they aren't as, because they don't have a real class, right? They can be like, okay, if this doesn't work the first time, that's all right. You want to add anything there?
I don't think so. At Nebraska, we run a ton of trainings. And one of the trainings we teach is the NRP training now, where they go from creating a Docker container all the way up to running on the NRP. And primarily students attend those, graduate students. And so it tends to be more kind of bottom up in that scenario, where the graduate students will bring this idea up to their PIs, be like, hey, look, this cool new thing that Nebraska is teaching us. It's very interesting and it works great. And then it kind of percolates up from there. At least that's been our recent experience.
Working? Yeah. Are those courses, is that coursework available for refactoring if, for example, we're building our own cluster and want to create our documentation based on yours?
Yes, so everything we do is open. So the Docker container one is a software carpentries program. I think it's in some incubator status, but we use it and it works great. The stuff that's very much specific to NRP would be more or less under that repo. And that teaches much more about like how to do Kubernetes and NRP stuff. We've worked in the past to kind of extend the Docker container one to include like minimal Kubernetes type command stuff. And that's still early in the process of working that type of material in. But the Docker container carpentries lesson is pretty solid, at least in our opinion. Any other questions?
And feel free to email me with more follow-ups if you need links or anything like that. My email's there if you need it.
Thank you. We're good. Then let's thank them again.